Visual analytics is the science of analytical reasoning facilitated by visual interactive interfaces. In contrast to machine learning or statistics, visual analytics couples human and computer closely together. Interaction design is an important component in visual analytics research since it facilitates the sense-making process. The purpose of this project is to evaluate, analyze, and improve a visual analytics system. Designed to solve the VAST 2011 Mini Challenge 1 from the interaction design and user-centered design perspective. This challenge is a spatial temporal problem. The data contains 1 million microblock messages with timestamps and location data. Some of the messages contain disease-related text such as flu, fever, headache, stomachache, and diarrhea. The challenge requested participating teams to create visual analytic solutions to identify where the disease outbreak started on the map and explain how they arrived at their conclusion. As the primary researcher, after examining all the 30 submissions of VAST 2011 Mini Challenge 1, I selected 8 systems to conduct further evaluation and analysis in 2 phases. At the first phase, I conducted a preliminary study of heuristic evaluation upon the 5 selected systems. This review helps me to understand the general nature of these systems and to abstract their common or unique features from certain subtasks. After receiving the IRB approval, I conducted a user study with a mixed research approach. 20 subjects were recruited from the campus with different major backgrounds and an even distribution of genders to attend my study. The accessibility of the systems and limited time of user testing do not allow all the participants to learn and test all the systems. Challenge participating teams all submitted project summaries and videos to the challenge jury, which provided us a rich list of data. I demonstrated captured screenshots and movie clips from those submitted videos side by side and asked my subjects to rate them in a questionnaire. In the questionnaire, subjects looked at 6 sets of printed system images and 2 movie clips and then answered the questions. There are 4 sections in the questionnaire: overall impression of the interfaces, geospatial visualization, time and weather, and miscellaneous. Subjects were asked questions such as if they can recognize the distribution of bloggers on a map and which visualization is more intuitive. Apart from this quantitative approach, I selected 4 participants from the 20 to attend an open-ended interview to discuss their reflections upon these systems. Our discussions were audio recorded as a qualitative data. Through the method triangulation of 3 different research methods, heuristic evaluation, quantitative questionnaires, and qualitative interviews, the research validity is ensured. I did analysis both upon the questionnaire and interviews. For the questionnaire, I also converted the result of each question into a visualization graph to help me with further analysis. Both good aspects and problems for each system were stated in the report based on 3 sets of design principles. For example, in System 3, the time controlling bar is on the bottom while the data and time display located on the top of the interface. So it takes more time for users to link these 2 together rather than having them closer by each other, which is a bad example for the principal navigation proposed by Benyon. From these good aspects and problems, some key points for a good design for this challenge has been concluded, such as the interface should be clean, neutral, and minimal. Based on the insights provided by the studies, I redesigned the award-winning entry Mobile Analymeter from IXD Purdue University. Basic structures were made, followed by detailed interface sketches. This is the final system redesign. In the new system, the interface looks clean and intuitive. It is composed with three main sections: Map, Overall Controls, and Time and Weather. It keeps some good features from the original design. For instance, keeping the three modes, by time, by people, and animation, to allow users to see the data in different dimensions. And it takes some amazing features from other systems. For example, now the overall time and time range could be easily altered by dragging the two white points on each side of the sliding bar. We are still conducting the user evaluation on the new design. Some preliminary results already shown that the new design has improved the user experience while analyzing the complex data.